Support for the series on women in science and tech comes from Genentech, dedicated to breakthrough science and social good that supports local communities. Because making medicine is just one way to make a difference. Genentech, the future of science is here. Online at gene.com/future.
Hello, I'm Kamla. My guest today is Julie Yu. She's a senior scientist at the Exploratorium, which is based in San Francisco. Welcome, Julie.
Thanks very much.
So, first of all, let's talk about the Exploratorium. What is it?
We are a museum of science, art, and human perception in San Francisco. And it's really a museum for all ages, and our goal is really to help people feel like they can figure out the world for themselves. So we create experiences inside and outside the museum to help people really be able to explore the world and understand things for themselves.
Did you ever think you'd work at a museum?
I did not. It was definitely not one of the career paths that were kind of made obvious to me growing up.
Okay, so how surprised are you now that you're working at a museum?
I guess somewhat surprised, mostly delighted that I get to work in a playland and focus on the things that are important to me, which include science and education and teaching.
Okay, so for you, science doesn't stop just with museum. It also goes home with you when you're cooking in your kitchen. Your twin passions are working at the museum and cooking in the kitchen.
That's right. I love to cook, and I actually think that cooking is what got me interested in science. I might not have put the labels to it. You know, one of my earliest memories is thinking about noodles, which I love to eat. And Asian noodles are mostly flour and water only. And I remember being a kid thinking that if noodles were flour and water, then why didn't they fall apart when you added them to water? And I was at home by myself one day when I was about 10 years old, and I set about figuring that out, or trying to.
So what did you do? You just took a bunch of flour and water?
I took a bunch of flour and mixed it with water and mashed it together till it seemed noodle-like, and I boiled some water and I threw it in, and sure enough, they did not fall apart. They ended up being a very delicious bowl of noodles.
So you kept working with the flour. Somehow you had this idea that if you put more flour into the water, it'll become like a dough-like thing.
Yeah, I had seen noodles made before, and I'd seen, like, my grandmother had made dumpling sheets, which are, I guess, flat noodles. So I had some sense of what went into them, but I didn't really understand, like, conceptually why, when you add more water at one phase, they fall apart into a gluey mess. Why that happens, whereas when you throw it into boiling water, they don't fall apart. That didn't really make sense to me just yet.
So one of the things that you do at the museum, you have something called science snacks, I think.
Yes.
So I went and looked it up on your website, and you have a thing on bread. You know, so this noodle dough that you made. What happens when we make bread?
So the basics of bread is actually very similar to noodles. When you hydrate the flour, when you add water to flour, two proteins get together and they form the thing that we call gluten. And gluten's kind of in the common knowledge universe now as something that people either avoid or want to eat or try to eat. But it's a complex of proteins, and it forms this matrix that gives both bread and pasta structure. And the ratio of flour to water will influence the final structure and texture, and that's the same for noodles, and it's the same for bread. And the idea behind all of the Exploratorium science snacks that you saw online is really to have folks engage with common everyday items and think about some of the science behind phenomena that they can create with those items, including cooking, including in your kitchen.
So when you're in the kitchen cooking, do you really think like a scientist if you're making rice and, say, I don't know, some Asian dish or an Italian dish?
You know, I don't know that I think like a scientist in or out of the kitchen. I think that the scientific way of thinking is just the way I think, and I actually think it's the way that many people think, being driven by your curiosity and being able to experiment and asking questions and thinking through scenarios. To me, that's what a scientific way of thinking is. So absolutely, if I'm in the kitchen, and I imagine anyone who cooks has the same thing, where, you know, maybe something's not exactly as you planned, you're missing an ingredient, or you don't have as much time as you need, or you can't follow a recipe a certain way, and so then you start making adjustments in your head. You make some prediction. Okay, I'm going to use this broth instead of that liquid or whatever. And then you try it and you see what happens, and maybe it works and maybe it doesn't, but you'll take that information and you'll use it the next time you're in the kitchen.
Okay. Now let's switch back to your work at the Exploratorium. What do you do as a senior scientist?
My home is the Teacher Institute, and we are a professional development program for middle and high school math and science teachers. So we've been around for almost 35 years now, and our main job is to take kind of the inquiry-rich learning experiences that people have at the Exploratorium and try to help teachers replicate those in their classrooms.
So you help teachers teach better?
We help them teach in an inquiry-rich way that is very student-centered.
So when you say inquiry-rich way, what does that mean?
It means that rather than
reading out from a textbook?
Facts or, like leading with vocabulary, we lead with phenomena and experience, and we have students generate their own questions, and we design both activities and basically the whole environment around helping students be able to explore those questions that they have.
So what has been the efficacy of this way of teaching? How do you measure it? How do you know that teachers have succeeded in communicating with their students better after having gone to the Teacher Institute?
It's hard to make a direct connection between a teacher's experience in the Teacher Institute and a student's result in a classroom. One, because there are so many factors, and two, because we really don't have that many ways to assess student outcomes. There's testing and assessments that the school uses as measures, and then there's the teacher's own assessments, formal and informal ways to assess. And then there's the feedback that they give us from coming to our programs. What we do know is that over our 35 years, we've had over 3,000 teachers come through the Exploratorium Teacher Institute programs, and many of them have ended up staying in the classroom. So we have one program in particular that's a teacher induction program for teachers in their first 2 years of teaching. And in the urban areas that are similar to the ones around the Bay Area that have high numbers of new teachers, many teachers, like almost half the teachers, leave within the first 5 years.
Why?
Because it's an incredibly challenging job. There's so many reasons for why it's more attractive to maybe do something else other than teaching, or why those teachers are the first to maybe be pink slipped out of their jobs. And we have now data from the first 20 years of graduates of our program that 90% of our beginning teachers stayed in the classroom for at least 5 years.
Okay, so you do have some data. Now, now you work not only with local teachers, but also with teachers from around the country?
That's right, around the country and around the world. We've had teachers and educators from all over come participate in our programs, which the easiest ones for non-local folks to come to happen in the summer. And so we have a 3-week institute where folks from around the country and the world and local Bay Area people come for 100 hours of professional learning with us.
And so you prepare the syllabus. When I say you, I mean you and your team. Mm-hmm. For the 3 weeks that they're there, you have the entire 3 weeks program scheduled.
Yeah, we have a 3-week program, and there are multiple classes that teachers can participate in depending on what they teach. Because we're in the Exploratorium, we really value the opportunity to choose different paths of learning. So teachers will work together in our classes on the museum floor at exhibits, and then we'll show them or work with ways that might happen in the classroom. In the Exploratorium, we have a giant machine shop where we build all of our exhibits, and during the summer, we take a portion of that and we build a smaller light-duty wood shop that's just for teachers. So teachers can build basically classroom versions of exhibits that they take back to school in the fall.
Oh, so this is very hands-on.
It is all hands-on.
Okay. We'll come to, I've been eyeing those things there. We'll come to
Sure.
your experiments. Now, you also work in Costa Rica?
Yeah, we have a couple of partners around the world, and one partnership we have is with Cientec, which is an organization in Costa Rica that has also been around for 30 years, and they focus on science learning in both formal and informal settings, not unlike the Exploratorium, except for they do not have a physical museum. They work through conferences and teacher organizations, and they do like family astronomy nights, but their focus is all around the country, all around Costa Rica.
And then you also work with Science for Monks, Dalai Lama's monks.
Yes, so that's another partnership that we have that's focused on monks and nuns who live in India in exile. So these are monks and nuns originally from Tibet, and they live in India, and we started working with some from Bhutan and Nepal, and the Dalai Lama has advised his community to incorporate modern science understanding in their training and education, and historically that hasn't been part of the monastic curriculum. And so we've been working with that group now for over 10 years, going over and sharing some of the way we teach science to the monks and nuns who are interested in becoming science leaders there. And then we also do basically science learning courses for some of the senior level monks who have never had a course in science in their whole lives.
And this is taught in English?
Well, we speak English, and then our partners there work at the Tibetan Library of National Library of Archives, and they have a science staff that their main work is translating science texts into Tibetan, and they serve as our translators during these workshops too. So they speak many languages, including English and Tibetan.
Okay. And the final thing you also do is leadership programs for teachers. This is different from the 3-week induction program that you have.
That's right. We have the 3-week summer program is for all teachers at all levels, and then we have a 2-year program for beginning teachers.
Oh, 2 years.
That's for teachers in the first 2 years because they need that constant support. And we realized to support them, they actually needed kind of people with the on-the-ground experience. And so even though our staff at the Exploratorium is composed of scientists and educators, we've been out of the classroom for dozens of years, some of us. So we have a complementary leadership program. These are teachers who are now further along in their career. They're ready for additional challenges and they want to contribute to the profession, but they don't necessarily want to leave the classroom. That's something we would like to support. And I think one of the greatest things about our program and our community is that we have these kind of differentiated programs for teachers, acknowledging that they have different needs depending on where they are in their professional path. And the leadership program is one that allows them to also develop in their leadership skills. And of course, is a huge support for our teacher induction program.
Now let's talk about what you have there. This is some things that you do. This is part of your science snacks.
Yeah, these are just some little activities that we engage with just to share kind of how we might think about science. This is a pretty low-tech one. This I travel around the world with, and actually when we work with the monks, this is the first thing I pull out just to share how I think about science.
So you travel with this around the world?
Yeah, and so I introduce them to my genie. So there's a genie in here, and I ask, do you believe me that there's a genie in here?
I'm going to say yes.
Okay, well, if they're yes, then we're done.
Okay, there's no genie.
So one question is, what do you believe? How do you know what you know, right? You can
because I read all the story, those fairy tales about genies.
So there's stories about them. Maybe you decide I'm trustworthy, and I just told you that there's a genie, and you can believe me. Or maybe you say, you know what? Those are just stories, and I just met you, so maybe there's not a genie. And so then maybe I'll provide you some evidence that there's a genie. And to show you that there's a genie, I will show you that he holds on to things.
Oh, wow. Is that a magnet?
And so it's a genie. It's not. Why would you say there's a magnet?
Because that looks like some sort of a wire.
Okay, so there's some sort of wire on here, and you say, oh.
So the wire will stick to a magnet. So there must be a magnet inside.
That's right. And so how would we test whether there's a magnet inside? I'm going to say actually it's not a magnet. It's a genie. So how could we test that? And so you're skeptical of this part, but this part has no metal, right? So if the genie holds on to that part, can't be a magnet. It's got to be a genie.
Well, it's got to be something. I don't know.
And so what do you think it is if it's not a genie?
I don't know.
And so we can go through this. And basically the nature of science is you have some observation, you make a prediction, and then you test that. And through that test, maybe you're refining your ideas. So you're still a little, I can feel it, you're a little skeptical that there's a genie inside, but I'm telling you, you might say, oh, you know, I don't know, whatever you think it is, there's tape, there's clay, there's not. It's not, it's a genie. The genie likes to hold on to things. And the thing about science is actually...
I wish I had a science teacher like you. You know, I would have learned far better.
Well, I mean, it's not too late. The Exploratorium, I mean, it's a lifelong learning process.
So what is inside? How are things sticking to it?
There's a genie holding on to things.
No, come on. That's fairy tale. What is inside?
So the nature of science is that actually the vast majority of things in our universe, we cannot just open up and look inside and see what it is, right? And we actually can't or shouldn't just trust someone saying what it is. We have to devise ideas and models and predictions and continually test
So
them.
I'm going to stop you right there. So It reminds me of this thing that I keep hearing all the time, first principles.
Sure.
Does that have anything to do with first principles?
Yeah, so first principles really are what, like, they distill down to the basics, the foundational science things that you learn in schools. The theories, but the ones that form up the underpinnings of physics, chemistry, and biology. So there are Newton's laws, for example, are these fundamental laws. We call them laws in physics, and there are theories and laws of gravity. There are basic ideas behind how molecules interact to have chemical reactions. There's evolutionary theory in biology. So there are these fundamental things like rules, basically ways to describe how the world works, from which everything else is built on.
So when we hear about Elon Musk saying that he builds from first principles, does that mean that he's not looking at things that have been done in his field before, but going back to the rules of physics and then saying, this is what I'm going to do?
I mean, I think it's a little of both. I think what's important as we get more and more sophisticated, as our understanding of the universe gets more and more detailed, as the things we build and create and engineer get more and more mysterious and further away from kind of the naturally built world, I think you spend your time working here, and what's important and what I believe he's promoting and what I agree with too is what's important is that you're never forgetting the fundamentals. Right? You should be able to explain anything that's going on by slowly dialing back and saying, does this make sense? Does that like follow my normal intuition around how physics works? And that's why, an 11th grader in physics class might feel like they're, answering questions or solving problems that don't really have connections, or they're doing an egg drop, which is kind of a contrived thing. But ultimately, they're building the intuitive skills and practices that are going to help them understand the more complicated things in the rest of the world.
Okay, we talked about first principles. Let's come back. What's that genie in the bottle?
It's a genie, right? And for the longest time, people made a guess about the sun going around the Earth, or how the planets moved, and the shape of the Earth. And until we developed enough evidence and took enough measurements to provide a different solution, and we were able to test those, those were the prevailing
You're
ideas.
testing me. What is inside there? I just want to know. What do you have inside?
So when I taught middle school, I brought Genie out on the first day of class, and the rule with the students was they could bring in whatever they wanted to test, because science is about understanding the world through experimentation. And so if you would like to test something, I'd be happy to do it. So if you don't trust my things, right? You have this is healthy skepticism. You don't trust what I have, so my Genie still likes your pen.
Yeah, but what is holding it? That's what I want to know. I mean, is it a glue? What is it?
It's Genie.
No.
You can try as you want, but
so how will we find out what that Genie is?
we will find out through continual testing. So if you have additional ideas, other things you would want to test,
What about this piece of paper?
let's try it. So can I ruin this a little bit?
Yeah, sure, go ahead.
All right. So what do you think is going to happen? It's a sheet of paper.
It's,
Ready? What do you
hey,
think?
no, you're holding it at the bottom. Let it go. Oh, I have no idea.
Yeah, it's a Genie. So
Man.
two guests today, me and my Genie.
It's got some sort of a glue, I want to say.
So how do we test that? What would a glue not hold on to?
Water. We can get.
Well, I mean,
we can get a bottle of water.
And then
Can we
what
get a bottle of
happened?
water?
We would drown the Genie? I mean, the Genie
I don't know.
can't
You
hold
said we
on.
can test anything,
Yeah.
so let's
So we would rinse the, tell me what the experiment we're about to do is.
I don't know. If you put water, if there's glue, it'll dissolve. I don't know. There's something in it that's.
So if we poured water and then poured it out, you want to inspect the water?
I don't know. We need a. But I need to know if you put water in it. Now you've really got me intrigued. You keep talking about this thing as Genie. I want to know what it is.
Okay.
Because you have now kindled my curiosity, which was your
That's
aim.
good.
Your aim was to kindle our curiosity.
Mm-hmm.
And that's what we don't get in a traditional classroom setting. When we read science and math, there's some dry equation that's put up there, or Newton's first law is explained, second law, equal and opposite reaction. But we have no idea what it means.
Yeah.
So what you're doing is you're needling us. I wouldn't even say kindling, because at this point you're let's find out.
Thank you. Okay, so tell me what I'm doing.
You're going to put water in it.
Is that enough?
Put more. Okay, and then let's take the water out.
Okay. Genie, sorry. It's a little bad.
Let's see if your pencil sticks to it now.
All right, let's see. Which side would you like?
The other side.
Oh, okay. Just want to make sure. Are you ready? What do you think is going to happen? Do you think we've taken away the glue?
I think you have. Oh, you're still holding on to it. I don't know.
Ready?
Yeah, I've give up. I don't know what it is.
Well, I've made it very easy for you because I've just told you it's a genie. You might need some water.
No, I'm going into a coughing fit because I don't know what that is. Okay, so how does that genie bottle end? How do the Tibetan monks finally figure out? Because they probably don't give up.
No, nor should you, right? I think that you can be satisfied with my answer that it's a genie.
I'm not satisfied.
I fully support that. And we can continue to do whatever tests you want.
How did you come up with that idea?
You know, this is an idea. It's really formed by the truth that there's a lot that we don't know in the world. Like most of the world is a black box. A lot of science is basically unmixing a world that comes mixed. You know, and for a physicist, that's, okay, I'm going to think about all the forces and I'm going to ignore the ones that maybe aren't as important here because I think the main forces that are interesting are, you know, in this scenario are X or Y. A biologist says, you know, what's inside that frog? And I'm going to dissect it and try to understand what's inside by opening it up. But really, you get to a point where we're limited by our perceptual systems. And we think like maybe the smallest thing in a frog is this little organ, but then a microscope gets invented and you realize there's actually these smaller things that we call cells. But before the microscope was just a black box, and then we actually see, oh, there are cells, and then maybe the cell is a black box, and you say, oh no, there's actually organelles inside the cell, and then there's a black box, and through more and more sophisticated techniques, first we guessed, oh,
it's like Alice's tunnel.
Well, I mean, that's science. I think that there are things called molecules, and I think that there are things called atoms. And those ideas, those models were formed before we actually had the techniques to go in and probe. And so there was some guess as to what was inside. And then the guess, many right guesses and many wrong guesses, right? But we've come to accept them as right or wrong through experience. So once you have a model that maps to the evidence of what you're doing, that's how we come to understand something. And the thing about science is we're always learning more, we're always changing, right? You have a model and all the evidence supports it, but then all of a sudden something happens and there's evidence that counters your model, then you need to fix your model, right? And that's how we come to a better and better and more refined understanding of the world.
So you said there's a model and observation, all of that. Now you've really got me addled because I want to know what is in that blue bottle. Mm-hmm. So how do I find out? Give me a clue. How do I find out?
We continue to do experiments, right? Your first thought, I mean, you're already doing it. Your first thought is, oh, it must be a magnet. And so then we did a test.
So you actually led us down the garden path because that's what everybody would think, because when they saw that, they said, oh, there must be a magnet. Because
some people think that. Some people think like, hey, there's a hook. Maybe you're hooking it. So yeah, so this bit is it's a little contrived. I'm trying to get us there. And it's analogous to people looking inside a cell. People looking, and then atoms are the smallest things. And because we can't just like break them open and look inside, but actually now our understanding is that atoms are made up actually of even smaller things. Inside that there are protons, right, neutrons and electrons, and that protons and neutrons aren't actually the smallest thing. That those are made up of even smaller things. So we continue to refine our understanding to more and more detail, and all of that stuff. It's not possible just to like open it up and look inside. Like I can look inside here what it is, but the majority of what we know and do, we cannot look inside. On the other end of the scale, like complex systems, like the environment, the whole human body, our genome, you can't just take a look at the whole thing and understand what is going. It's way too complicated for us to understand what's happening. And so we try to describe different parts of it and try to put it all together in a way that makes sense. But we have to compare it to the evidence of what actually happens. And when those two things match up, we say, okay, this is a believable model. Like we can work with this, and we're going to continue to refine it by continuing to get more evidence.
Has anybody got that answer right?
Yeah, the people who say there's a genie, they're absolutely right.
You really got me stumped. You keep saying genie, and I'm not going to be able to rest easy. Maybe I'll go home and ask my husband.
I think you should ask yourself. I think you have.
No, I think I need a clue, because it's not glue, it is not magnet, and maybe it's a mixture of glue and magnet.
Yeah. So how could we test that?
I don't know. I don't know how to get a magnet out, because I have no idea.
Yeah, the one thing I didn't bring was a magnet, but we could, I could come back and you could find one. And we can see.
This one.
That's a paper clip. But I guess, if you had an external magnet, you could feel for a magnet. But again, we stuck in a number of things like your paper and my pencil that have nothing to do with.
Yeah, we threw away the paper. Okay, yeah. So I don't know. I think I'm going to admit defeat.
I wouldn't admit defeat. I would just admit that we need to continue to do experiments.
And that's how you keep your teachers, what's the word I'm looking for, hooked? Because I'm sure you show this to the teachers?
This is something that we have shown with teachers, to just talk about the nature of science. Because this, maybe you could go through life and actually be okay, not ever knowing what's in here.
Many of us go through life not knowing a lot of things.
That's right. And the pursuit of science is the pursuit of being able to understand the world a little better. It is one explanation of the world. And that's the idea of the Exploratorium, is actually not to teach you necessarily how magnets work or what's inside the bottle. It's to help you feel like you could figure that out for yourself, to help you feel like, you know what, I could continue to do experiments. And so actually for you to admit defeat is heartbreaking to me. Instead, I want you to think about, if we had this, like if we had the magnet, then I could try this. Or if we had this other thing.
If I had a cup of hot water.
There you go.
And if I poured it, then I would probably have some idea.
You can hear some tiny screams from the genie.
Maybe. So I don't have access to any of. That's why I'm saying I'm admitting defeat, because I don't have things that I would maybe stick it in the microwave.
Absolutely. So we can admit defeat in the moment.
Yes.
And the path forward is, okay, so actually now we needed to bring a longer list of things, because if we had a microwave or a hot pot or something, there are many more things we could test, and that would.
Or I could just crack it. I could just drop it and see.
We could wash it clean with my tears. Yes.
Julie, we're going to talk. We're going to have part 2 of a conversation with you. So stick around.
Okay, great.
Join us next week for another conversation with Julie, and we're going to be exploring about everyday science. She has more experiments that she's going to show us. If you missed any of our shows, you can catch them on our YouTube channel. And as always, thank you for tuning in.
Support for the series on women in science and tech comes from Genentech, dedicated to breakthrough science and social good that supports local communities. Because making medicine is just one way to make a difference. Genentech, the future of science is here. Online at gene.com/future.